Okay, we're going to talk about things that are in the middle, the median and the interquartile range of a list. Okay, we're going to find the median and the interquartile range of a list and work out whether there are any outliers. So first of all, I want you to think that there's a list inside this box, all right, a list of numbers. There they are, blum, blum, blum. So we could, if we wanted to, find the number that is halfway in the list. And obviously you guys know from GCSE that's called the median, but I'm going to refer to it as Q2. Or we could find the number that's a quarter of the way into the list, which of course you all know as the lower quartile, but I'm going to think of it as Q1. Or we could go find the number that's 3/4 of the way into the list, which you think of as the upper quartile, and I'm going to think of it as Q3. Okay, so we're going to find Q1, Q2, Q3, or the lower quartile, median, and upper quartile of this list in front of me. Okay, let's begin. So we're going to find the lower quartile first. The lower quartile is found by doing a quarter times n. Now what's n? N is actually how many pieces of data we have in our list, and if we have a count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the idea? So we're just going to count those up. We've actually got 30 pieces of data, so I'm going to write this as a 30. Okay, so a quarter times 30. Now, quarter times 30 is 7.5. So we're looking for the 7.5th piece of data. Okay, look at this. All right, my new button. So the rounding rules are here. So if this number here comes out as not a whole number, which is a bit weird, mine isn't a whole number, is it? Then we round it up. So what we do is we're going to round it up to the 8th. Now this is really weird, but if it came out as 7.25 or 7.15 or 7.05 or 7.01, you would still round it up. So it's not the same rounding rules as you normally apply. It's basically if it doesn't come out as a whole number, it gets rounded up. So that's that one. If it is a whole number, we'll do one of these in a minute, then what you do is you take the average of it and the next one, all right? The median will come out like that, so I'll show you what that means. But it's really important that you're happy with those two rounding rules. So not a whole number, round up, is a whole number, average out, that and the next one. So I've got 8th now. 8th number, let's count it up. 1, 2, 3, 4, 5, 6, 7, 8. He's there. So I reckon that Q1 is 17. Okay, let's do the next one. Let's do the median. So Q2 is a half of 30, which is the 15th. Right, what do my rounding rules say? My rounding rules are now here. If it is a whole number, this one, we are going to take the average of the 15th and the next one. So what we're looking for is the average of the 15th and the 16th. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm actually going to average out 24 and 25. So 24 plus 25 divided by 2, I think that Q2 is coming out as 24.5. Okay, next one. Q3 is 3/4 of 30, and 3/4 of 30 is 22.5. So I'm looking for the 22.5th. Is it a whole number? No. So it's this one. If it's not a whole number, then round up. So I'm going to round up to find the 23rd. And the 23rd, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3 is there. So I think he's 36. So Q3 is 36. Okay, let's move him up. And we're going to find the interquartile range. So I reckon you probably remember how to do this from GCSE. It's Q3 minus Q1, or upper quartile minus lower quartile. And in my case, it's 36 minus 17. Now make sure that you put this line in, because this acts as your method, even though, of course, you can all see that it calculates to 19. Now, what is the interquartile range? I'm just going to bring this back here. The interquartile range, because I think sometimes at GCSE we do it, but we don't actually know what we've actually done. It's the upper quartile, which is this one, minus the lower quartile, which is this one. So what it actually gives us is it gives us this middle 50% of the data. And what it does is it ignores these extremes, the top 25% and the bottom 25%. Okay, let's move him back. That's what he's up to. So now what we're going to do is we're going to have a look for outliers. Now In order to calculate outliers, let's first of all think what they are. Now, an outlier is an extreme value in the data. All right, so it's an extreme value in the data. Something that's really big or something that's really small. And you can probably guess, looking at it, that 79 is probably looking a little bit like an outlier. Now, in the exam, they usually give you the formula. You don't need to learn this, but the first formula for the outlier is found by Q1 minus 1.5 lots of the interquartile range. And the next one is Q3 plus 1.5 lots of the interquartile range. So as long as our data is in between these two limits, they won't be an outlier, and anything outside of these limits will. So let's just put the numbers in and have a little look. So Q1 is 17 minus 1.5 lots of the interquartile range, so 1.5 lots of 19. And if we put that into a calculator, my calculator's giving me 11 minus 11.5. And Q3 is 36 and plus 1.5 lots of the interquartile range, which is 19. And I'm getting for that 64.5. So any data that is in between minus 11.5 and 64.5 is fine. And anything that is outside of it, so lower than minus 11.5 or bigger than 64.5, is called an outlier. So you can see really clearly that 79 is clearly an outlier. 79 is an outlier. Okay, that's it. Okay, here's one for you to try. Before you do, please note that the stem and leaf is around the other way, so you have to start here. All right, 16, 20, 35, 37. So start your counting from the bottom. Okay, pause the video, have a go, and here's the answers. Okay, let's go. So Q1 is 1/4 of 22, and 1/4 of 22 is 5.5. So we're looking for the 5.5. The rounding rules state if it's not a whole number, we round it up. So we're looking for the 6th. Okay, remembering to start down the bottom. 1, 2, 3, 4, 5, 6. There he is, 47. So Q1 is 47. Make him look like a 7. Okay, next one. Q2 is 1/2. My pen's getting sticky. 1/2 of 22. That's the 11th. The rounding rule said if it is a whole number, then you average out that and the one above it. So 11th, 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's the average of 60 and 62. 60 add 62 divided by 2. Q2 is coming out as 61. Okay, so Q3 is 3/4 of 22. 3/4 of 22 is 16.5. The rounding rules say if it's not a whole number, we round it up. So that's the 17th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 76. Okay, so Q3 is coming out as 76. Okay, interquartile range. Interquartile range is Q3 minus Q1. So Q3 is 76 minus Q1, which is 47. So I think that's coming out as 29. All right, are there any outliers? So the outliers are found by Q1 minus 1.5 lots of the interquartile range and Q3 plus 1.5 lots of the interquartile range. So Q1 is 47 minus 1.5 lots of 29, and that is coming out as 3.5. And Q3 is 76 plus 1.5 lots of 29, and I think that's coming out as 119.5. So any numbers between those are fine, they're not outliers. Have we got any numbers that are smaller than 3.5 and bigger than 119.5? Okay, I don't think there are any numbers because the lowest number is 16, the highest number is 96. So in this case, there are no outliers.